All right, this is like a projectile. I love these questions. What could be more fun than throwing rocks? Well, maybe jumping. This is a distance jump. So you should always draw the scenario here. So if you think about, this is a function that the dependent variable is the height. It depends on the distance. Okay, independent variable is the distance. So as we increase the distance, we have to also increase the height. If you think about a long jumper, if they are going to go, they have to get some height. I know they're focused on distance, but to increase that distance, they also have to increase the height because we're trying to work against gravity, right? All right, so here's a function for this jumper, and of course it'd be different for other jumpers, I'm sure. We want to find out how far the athlete jumped. Okay, so how far they jumped and how high they jumped. Now, this one seems like here, how high they jumped, that's the maximum height. That's got to be the vertex, right? And then how far they jumped, well, let's think about that. So what I have here is the starting point here, the distance is at 0, right? So I've got a 0 distance here. And then we're trying to find out where they're going to land. So they're going to jump right here, and they're going to go in this kind of like some kind of a very somewhat flat-ish quadratic shape, right? How do we know it's pretty flat? Well, this is the coefficient, -1/49. So, you know, I didn't draw this to scale by any means, but you kind of get the idea. And at some point here, we're going to have our vertex. So this is going to be our vertex, right? Where is that? Well, we don't know yet. But what do we know? Well, we know that we start at a 0 height before we jump, and then at somewhere we land. This is our landing here, so we land here. This, we know, has a height of 0. We know this is 0, 0. Okay? But what is the distance? We don't know what the distance is, but we know the height is equal to 0, right? And that's really what we're trying to find. I can't really use this point here to find out what the axis of symmetry is, right? So, well, let's go ahead and write down what we know. So we're trying to basically find out what the roots are. We know one of the roots. That's the starting point, just by basic understanding of jumping. We know it's there, but where do we land? Okay, so let's go ahead and solve that equation. So we have our equation there. The height when we land is going to be 0. So I'm going to say h of d is equal to 0. Okay. And I have -1/49, and I have d squared minus 28d. Okay, and I can divide both I can multiply both sides by -49, and then I'm just going to have 0 is equal to d squared minus 28d. If we can factor, we should do that first, which this is easily factored, right? So d times d minus 28 equals 0. Okay, so d equals 0, we know that. Or d equals 28, and that would be 28 feet. Okay, we already knew this one here because we could see it, and we just know that when we start, the distance is 0. That's where we took off, right? So we're at 28 feet, so that's how far they went, 28 feet. And so I guess, you know, I could do a few things, but what I could do is use symmetry, okay? Because between 28, we know this is 28, and 0, that vertex is going to be halfway, right? So that's going to be at, what's halfway between 0 and 28? It's 14. Okay, there are other ways to determine that, but why not use that, especially with these numbers? So 14 would be at the vertex, and how do I find out what what is going to be h of 14, that height? So let's go ahead and substitute. So h of 14 equals negative 1 over 49 times, what is it, 14 squared minus 28 times 14. Okay, so which is equal to negative 1 over 49 times 14 squared is 196, and then that's going to be double that, so it's negative 196. I know this because I already did this before with another student. So now if okay, well, basically it's going to be positive. And if you divide that by 49, or times it by 1 over 49, it's going to be 4. So 4 feet high. All right, so this is the maximum height here, is 4 feet. So the height it's at 4 feet high. All right, so how far did he jump? How high did he jump? 4 feet. How far? 28 feet. All right, that's it for that one.